welcome software engineer from Google, Naganov, and product manager from Google, Alexei Masterov.
Good day, ladies and gentlemen. My name is Alexei Masterov. I'm a product manager at Google, and I'm here today to talk to you about Google Chrome developer tools. Before we begin, let me ask you a question. How many of you in the audience are web developers? Raise your hand. OK, great, almost all of you. How many of you know what Google Chrome developer tools is? OK, not many. Good. So hopefully by the end of today's talk, you'll learn a little bit about what Google Chrome Developer Tools is and how you can use it to make your web applications better. And this is roughly what we're going to talk about today. So let's begin by talking about what is Google Chrome Developer Tools. How many of you know what a Firebug is? OK, almost all of you. So Google Chrome Developer Tools to Chrome is what Firebug is to Firefox. It's not a port of Firebug, though. And one notable difference is it's included as part of Chrome distribution. So when you installed Chrome on your computer, you already have Google Chrome Developer Tools installed with it. Another important thing to note is some of you may know and may have noticed that Google Chrome Developer Tools looks just like WebKit Web Inspector. Well, that's because it is WebKit Web Inspector. It's running on top of the V8 JavaScript engine, which our friends and team members from Denmark have built. And it gives us some extra power. But essentially, it's WebKit Web Inspector. And at this point, I'd like you to welcome Mikhail Naganov, who is a software engineer on the DevTools team, who is going to tell you about how you can use Google Chrome Developer Tools to make your web applications better. Please welcome Mikhail Naganov.
Okay. Thank you, Alexei. My name is Mikhail Naganov. I'm software engineer at Google, and I'm working at Developer Tools. I'm pretty excited being here in Tokyo and presenting to you. And I'm also very excited with capabilities of modern web applications, which are now really, really close to capabilities of classic desktop applications. And I also know that creating modern web applications is a really, really hard task. And if you even put aside things like browser compatibilities and server-side issues like fault tolerance, load balancing, there are still lots of work to do. You need to create good, attractive, sleek UIs that are responsive to user commands. You need to make your application load quickly. You need to eliminate JavaScript bugs that can occur in your code. And this is all really hard, and we know that. And that's why we have developer tools. And let me just show it how can you use developer tools for solving your everyday web development tasks. So I will have 5 stories. The first story is about how you can use developer tools for experimenting with your UI to make it better. So this is Chromium. I'm invoking developer tools by Command Option I key combination on Mac, and on Linux and Windows, you should use Control-Shift-I. So here it is. Right now, developer tools started in a docked mode. It's docked to the main window, but I can also undock it as a separate window, which may be more convenient for certain desktop layouts. And let me open this Google page. This is not a current version, because the current version has a pretty complicated design and internal design, and this is a simpler version. So, and let me explain a bit what do you see here on the screen. So here is the strip with icons, and each icon represents its own panel. And right now I have Elements panel opened. And Elements panel is a full-featured DOM editor. So on the left you see the live DOM tree, and on the right you see different panes that display styles, metrics, properties, and other things for the currently selected node. So let us experiment with simplifying Google page design using developer tools. You know, it looks simple right now, yes, but we can make it even more simpler. Let's do it. So first of all, I want to remove those links on the right. I'm locating them in the DOM tree by using this little inspect button. And now I can simply remove them by using context menu. And they are gone. The next thing, I want to try to hide this I'm feeling lucky button. For this, I'm editing its style. I'm setting its style attribute to display none, and it's gone too. By the way, I can experiment with attributes, with setting and unsetting them by using those checkboxes on the right to each individual style rule. And so let's now move this Google search button to the right from the input field. To do this, I'm copying its contents as HTML. And now I'm editing as HTML this table cell on the right and inserting this source code here. And the button is now on the right. Let's hide the original button the same way. OK, it looks simpler, right? But that's not enough. So I see this duplication of Google name, both on logo and on the button. So let's just edit the value for this button, its caption, and remove the name of Google from here, and add the exclamation sign. Even simpler. But now this button is too small. So let me open the metrics pane. And here I can see all the dimensions for the currently selected node. And let me just edit this width, its width. Wow, so now it's more discoverable. So you see how it's easy to use the Elements panel for experimenting with your UI and exploring how UI of other applications work. But that's not all about this panel. I also can open a console. And our console supports Firebug API. So for example, I can start monitoring events for the currently selected node. And you see when I'm moving my mouse over this edit, or when I type in something in it, I see the live stream of events. And I can expand properties of each individual event and see all of its properties. And this is great when you're building interaction of your UI. OK, let me unmonitor events for this node. OK, so this is how you can use developer tools for building great UIs. The next demo is about analyzing network activity. Why it's important for you. You need your application to start instantly. Otherwise, while it's loading, people will switch to another application and completely forget about yours. This is bad for you, right? So you need to know if your application loads slowly, why it loads slowly. And we can show it to you. So we have a panel that's called Resources. And let me show you how it works on the sample of Gmail. So I'm logging into Gmail. And I'm authorizing. So now Gmail loads. And what I see here in the resources panel, I see the list of resources that are loaded in this particular application. And I can view headers, all the requests and the response headers and parameters. And of course, status codes for each of the request. And for those resources that has actual contents that have been loaded with, for example, OK code, I can see their contents for HTML, for graphics, for other stuff. And this is pretty handy. And what I also can see when I switch to this time graph are exact timings for each resource. And what we have added recently are the detailed timings for each of the networking activity, like DNS lookups, SSL interaction, proxy. So pretty much of all you need. So you can look at this graph and see which resource is loaded slowly and why. You can also look at the size graph and see which resources are really big and maybe you need to do something with them. For example, you can compress them or you can load them lazily to achieve better start time. You can, of course, filter by the resource type. Okay. So this was how you can use resources panel for analyzing your network activity. The next demo is pretty exciting. This is about debugging JavaScript. Please raise your hands. How many of you spent hours trying to investigate why your application doesn't work? Huh? Not so much? Your application works without errors. That's great. Mine are not. So let me show you how you can use debugger in developer tools to fight with bugs. So for this demo, I will be using hovercard sample application from Google Closure library. So Google Closure library is a JavaScript library for building rich UIs, like in Gmail. And that's not surprising because Closure was initially developed for Gmail UI, and then it was open sourced. So this demo shows you hovercards. A hovercard is this rectangle that displays, for example, contact information. It looks similar to what you can see in Gmail. And they are displayed when I'm moving my mouse over those rectangles. And let me now open another version of this hovercard, a broken version, which looks exactly like the working one. But for some reason, it doesn't work. It doesn't display anything when I'm moving my mouse. So let me use the scripts panel from developer tools to figure out why it doesn't work. So here, in the bottom right corner, let me zoom in, you see this counter of JavaScript errors that have occurred on your page. And when I'm clicking on it, I see those errors in the console. And I can see call stacks that produced those kind of error. And of course, I can navigate to the code that caused this problem. So in this case, this is because the system cannot read a property of an undefined variable. And let us figure out why. So I'm navigating to the caller of this function and setting a breakpoint here. And so when I'm now moving my mouse, I'm on a breakpoint. Let me explain a bit what you see here on the screen. So on the left, it's your JavaScript code. You can, it's actually alive. So you can move your mouse over function definitions, over variables, and over, for example, this, and see all the properties of it. This is very convenient, we think. And on the right, you see the current call stack. You see local variables, global variables. You see breakpoints. You can manage them from here. OK, now let's return to this problem. So why the application doesn't work? I see that trigger is undefined. And it's not surprising because it's actually defined here in another branch of the if statement. So that's an error. And maybe I should, so I see that target is actually defined. And target is a target of an event. So maybe I should just pass target here. Let me check this. I'm editing my code here in the debugger. Now I'm continuing execution of the application. Wow, and it starts working, and I see no more errors. So to recap, what you have just seen, I edited the code of my application right here in browser without the need to reload it, without the need to restart my actions. So I just edited it, and the developer tools updated the code in the virtual machine that runs JavaScript. So this is insanely great for increasing your productivity. So when you're debugging your code, you say a little error, like you see that this if statement should have negated expression, like not equals, but not equals. And you just change equals to not equals on the fly and continue debugging your execution. So that's great. Okay, I hope you're all impressed with this kind of capabilities of DevTools. Now let's talk about performance. I really like that modern JavaScript engines are so powerful, they are so fast, and the current client hardware is also so fast that you can, for example, create 3D games in a browser. That's entirely possible. You can do 3D rendering, you can do physics simulation in JavaScript. That's very exciting. But you know that when you will try to make such things, you encounter performance problems. And as you also know, the 90% of time is usually spent in 10% of code. And you need to be able to find those pieces of code to optimize them. This is why we have built-in JavaScript profiler. Let me show you how it works. So this is a demo from Chrome Experiments project. It was developed by a Japanese programmer, Uyuyama-san. And what it does a 3D rendering in JavaScript, and it displays it using HTML5 canvas element. So this looks pretty cool, I think. And let me profile it. So I'm opening the profiles panel, and now I'm start to record. Now I'm causing this application to render stuff. Okay, that's enough, I think. And now what I see on the right is the full profile of this application, how it renders this image. I can see timings for each function. And I see, of course, I can navigate to the source code of each JavaScript function. And besides JavaScript functions, I also see calls that are made to DOM. In this case, to HTML5 canvas DOM element. And I can expand call stacks. So I can not only figure out which individual function contributes to consuming CPU time, but also I can see the most frequent call paths. So you can optimize on the level of call paths in your program. This is great. This can really help you. Okay, but you also not only can identify performance problems this way, you can look at how your application works. For example, in this case, we see that the rendering is run on timer intervals, and it renders floor and the model of the phone separately, and they're both using the same underlying function that calls canvas. So this is pretty nice. But JavaScript profiler cannot solve all of your performance problems. This is why. Some of the animations can be done by manipulations with CSS attributes to make it in a browser-independent way. And in this case, even if your application runs slowly, you profile it, and you see that actually JavaScript is not executed so much here. But the application is still slow. Why? This is because browser is a really complex thing. So even change that looks very simple in your JavaScript, like changing CSS attribute value, this can result in very, very much work to be performed by a browser. It needs to recalculate styles, to relay out your content, and to display it to user. And if you make it frequently, your application may display this animation slow. The users will notice it and will say, what the heck, why your application is so crappy? This is unacceptable. So this is why we have built another panel that is called timeline. Let me show to you how it works on this ZP example. ZP is a small component that can dynamically display and hide content. And this is done in a browser-independent way by just manipulating with CSS attributes. So let us open timeline and also start recording the events. So now I'm collapsing and expanding it. And what I see here in the timeline, I see the sequence of events on the left. What's important? I see not only JavaScript events. I also see browser events, like style recalculations, repaints, relayouts. What's also great with this panel, it detects such things like sequences of timers that create this animation. So in this case, it joined all the timer events in the hierarchy. So, and I can look up in the code to see how it's done. So we are setting the timer fires, we are doing a little piece of animation, then we reset this timer and set a new one, and that gets repeated. Okay, and we see that this sequence of timers has caused a sequence of style recalculations, which result in repaints, in relayouts and repaints. For this case, repaints and relayouts was very, very fast. So their duration 1 millisecond or less. That's why the animation is smooth. But in case if they will take a long time, you will notice non-smoothness of animation. And from this, using this timeline, you can see why this happens. And you should apply optimization techniques like maybe caching your style changes or rendering offline. Okay, so there is a great way for doing that. And from this panel, you can figure out where is the code that you need to optimize. Okay? So that was performance demo. And the last one is about memory. Why do you need to understand memory usage of your application? After all, JavaScript is a garbage-collected language. So it looks like you don't need to worry about it, like in languages like C++. So you can, so virtual machines should make memory management easier for you. That's right, but modern web applications process more and more data. And if you don't dereference your objects, they still remain in virtual machine memory. And as you are starting to have more and more of them, the memory usage can grow. And finally, the browser can even crash. And your user will complain, why? I remained your application for an hour, and it crashed my browser. Happily, it was Chrome, so only your tab was crashed, and other tabs are working. But it's still bad, right? So we need a way to identify memory leaks in your application. And that's why we created a JavaScript profiler, or JavaScript memory profiler. So let me again open the hover card sample. So you see on the bottom, there is a log. And each time I'm moving my mouse, a new record is added to this log. And let us look at how many memory does it take to make this log. So I'm going to Profiles page. I'm taking heap snapshot before I'm doing anything. And now I'm moving my mouse, creating events, and taking a second snapshot. And now I can compare them. Oh, this one. Yeah, and from this comparison, I see that I have created 100 of mouse events. I have created 4 dozen of HTML div elements. And I can see how many memory did it take. So when you're developing your application, you can focus on such things like if you're creating a memory leaks in operations like opening a document and then closing it back. So you can take a heap snapshot before you're doing anything, and after and compare them and see if you have any leaks. So this was the last demo. Thank you for your patience. And I'm passing control back to Alexei.
Thank you, Mikhail. Thank you very much. I hope you guys have enjoyed the demos. And what you've just seen is how you can use developer tools to make your web applications run faster, crash less, and how you can use the DOM tree editor to create mocks and make your UI better. And I just wanted to point out to you some of the new features that Mikhail has mentioned in his presentation. But before I do that, I want to tell you about Chromium release cycles. So Chrome has 3 different release paths: a stable, beta, and dev. Stable is what most of the ordinary users use. It gets updated every once in a while whenever the new version of Chrome comes out. Beta gets updated a little bit more frequently, and beta is where we preview some of the features that will make it into the stable. It's a bit less stable for some of the people who want to see new features, someone who feels more adventurous perhaps. And finally, there is a dev channel, which we try to update once a week. Doesn't always happen, but most of the time we get it once a week. And that's where all the action happens. That's where you can see all the new features, all the bleeding edge stuff that some of which you just saw. So if you are a web developer, I would encourage you to get on the dev channel. That's where you will see all the latest features, and that's where you can experiment with all of our technology. So the first thing you've seen, and some of those of you who've used Firebug will be happy to know that we've implemented this shortcut. Command-Shift-C on a Mac and Control-Shift-C on Linux and Windows will open web developer tools in an inspect element mode. So you can go straight to the element that you wish to inspect. The second thing that Mikhail showed you was live editing of JavaScript. Again, why is this so cool? Because you don't actually need to refresh your browser to commit your changes to the virtual machine. As soon as you change it in the scripts panel, it gets applied immediately, and you can continue the execution. So it's really handy for fixing bugs and increasing your productivity. And finally, I want to show you a feature that I'm showing it for the first time. So you're the first audience that's going to see it. It's called DOM breakpoints. And Mikhail is going to demonstrate to you how it works.
OK. Thank you, Alexei. I'm pretty excited to demo this new feature to you. So let's get back to Chromium. And I'm opening another closure sample, which is called tree control. So tree control is a browser-independent tree in which you can dynamically expand and collapse nodes. And let us look at how it works using DOM breakpoints. So I'm in Walking Web Inspector, go into Elements panel. Now let's see how those nodes are organized. So you see that this row is a div, and inside it has this children div, which contains children, not surprisingly. This is for the node A that I had expanded. And for the node B, I can see the children div, but it's empty. This is because children are populated lazily in the moment when you are clicking on this node. So let me set a DOM breakpoint here. I command DevTools to break on subtree modifications. Now when I'm trying to expand this node B, I'm on a breakpoint. It's like a regular breakpoint, so you can do pretty much everything that you can do on a regular breakpoint. But it was activated at the moment when my code was trying to modify the inner HTML of the node. And if I continue execution, I can animate addition of each node to this tree, which is great, I think. So, and you can control those DOM breakpoints from this DOM breakpoints pane. So I'm now disabling this breakpoint, I'm continue, and the tree is populated. OK, so thank you again.
Great. So this is the DOM breakpoints feature. And with this, I think we're going to end our presentation. But before we do that, I wanted to show you some of the important links. This is the DevTools project, where you can go if you're interested in learning more about Chrome DevTools. And this is the link where you can go if you're willing to contribute to the project. So for example, if you have some cool ideas for us, or if you found a bug in DevTools, you can go to crbug.com/new and submit a bug. And if it's a DevTools bug, please include that in your summary so that we look at it and we address it in a proper manner. If it's a feature request, also please use the words feature request. And with that, I'd like to open the microphone for Q&A. If you guys have any questions for us, there's going to be a microphone. We'll be happy to answer them. ありがとうございます。So are there any questions?
日本語でいいですか？日本語でいいですか？JavaScript を編集した結果を元のファイルに反映させる良い方法っていうのは検討されているんでしょうか？
Sorry, I switched to English channel just a few seconds. Can you just repeat your question, please? Sorry.
ライブでJavaScript を編集することができるという話なんですけれども、それはメモリ上だけの話ですよね。
Yeah, right. So, yeah, it's not get pushed to your server. Yeah. So, after you fix the bug, you have to return and edit your code on the server. Yes, that's right.
わかりました。例えば編集前後のディフが取れるととっても嬉しいと思います。
Oh, see the difference between your edits, right?
Yes. Okay, so that's actually a feature that was requested on our bug tracker, and perhaps we're going to add it, but currently it's not yet available.
Yeah.
There is one thing that we have for you though. If you're using Eclipse, Eclipse editor, Eclipse IDE, we have a sub-project called Chrome Developer Tools for Java, which you can use together with the Eclipse IDE, and then you can edit your code and debug it from within the Eclipse. So it could be a little easier for you at this point. But we might add the diff feature in the future. Thank you. Any more questions?
Okay.
Thank you very much for your presentation. My question is about extension for Chrome Developer Tool. For example, take Firebug as an example. Firebug has a system for extension like a YSlow or Google Speed Tool. Is there the kind of the system for Google Developer Tool for third parties?
Yes, I've got the question. Not yet, but we are actively working on it. We understand importance of being able to add extensions to developer tools, and we are actively working on it, so it will be coming soon.
I see.
Thank you.
So just to add a little bit more detail to that, as you probably know, Google Chrome has a great extension system, and the system that we're working on for Chrome Developer Tools is going to be based on that system. So it's going to work quite similar to how the current Chrome extensions work. Anyone else?
jQuery のような、複雑な一行でまとまったような JavaScript のデバッグ等は簡単にできるようになりますか？
I believe.
Okay, so let me make sure we understand the question first. I think what you're asking is if there is an obfuscated or minified JavaScript that all appears as a one line in the code.
Yes.
Is that the question?
Yes.
Okay, yes, so that's another requested feature that we're working on, and perhaps we could add some support to deobfuscate it. It's not that easy to do in a sort of transparent way, but we are working on that. Yeah, it's currently not available.
Thank you.
One thing I can suggest, though, is there are a number of Chrome extensions that allow you to do that. So if you, for example, if you're looking at some site that has an obfuscated JavaScript code, you can look at all these different deobfuscators, save the page, put it through the deobfuscator, and then try to debug it locally. So that's how I've been doing it, to be honest with you. But yeah, it would be great to add that straight to DevTools so you can get it with a click of a button. Anyone else?
Do you have any plan to integrate the special integrate for Clojure libraries for Chrome extension? Chrome toolkit.
Okay, but what are you talking about? So Clojure, it also has minifier, and that's was like in previous question. And what else specific is in Clojure?
Sorry.
So what type of integration are you looking for?
Yeah.
I can imagine the integrations, the specifics, but now I'm wondering which library I have to take while I am the Clojure library. So if is there, do you have any favor to use Clojure library and Chrome extensions?
Using Clojure library and Chrome extensions.
We don't specifically favor Clojure library because it's another Google product. We try to support all the libraries out there in equivalent manner.
Or are you asking if we are planning to use Clojure library in development?
Yes.
For DevTools and for extensions, right?
Sorry?
So your question is, are we planning using Google Clojure library for development inspector itself and its extensions?
Yes.
Okay. So yes, we use some approaches that are in Clojure library, but we have a bit different targets. So Clojure library is for building browser-independent web UI. And DevTools, they are connected to specific browser, to WebKit Engine, which is used in both Chrome and in Safari, for example. And we just don't need all of the things that are done in Clojure to make it browser compatible. So we can focus, for example, on things that are only available in WebKit. And you can see that in our code. For example, we use WebKit-specific CSS styles and other things just to make our application look better. So it's partially yes and it's no. So you can, of course, you can use Clojure source code when you are developing your, you'll be developing your extension. But it's not required. And that's because you don't need the full power of Clojure for developing DevTools itself and web extensions. Have I answered your question?
Yes, thank you.
Okay, thank you very much.
And one thing to add to that, I think some of you hackers out there may be interested in knowing that developer tools is actually written using HTML, CSS, and JavaScript.
Yeah.
And in fact, if you go to our homepage, you can find out that it's quite easy to inspect the web developer tools itself. So you can actually look at our code. We don't obfuscate it for that exact reason. We want you developers to look at it and, perhaps borrow something from us, perhaps tell us where we made some mistakes.
Yeah.
So you can actually look at our code and see how we've done it.
So we have last 5 minutes.
There's a question over there.
We will have actually office hours after this session, so you may think a bit more on your questions. Yeah.
Right, but I think we have a question over there, right?
Okay. Yeah.
Yes.
Can we debug Chrome extensions by the DevTools?
Yes. Yes, there is a link from our homepage to both the tutorial and the video that shows you exactly how to do it. And in fact, it's quite easy. If you know about developing Chrome extensions, you just click on the background.html page, and that opens the Chrome developer tools
Then
on the background page.
there
So
is some differences between them. And for example, there is a limitation for local storage for ordinary HTML JavaScript. But for Chrome extension, there is no such limitation on the Chrome. Then how can we tell that?
I guess I didn't got the question. Maybe.
So there are some differences
Yes.
between Chrome extensions
And regular web
regular
applications.
web apps.
Okay.
Yeah. So
And what are
can we see some of them?
what
on
differences?
DevTools? No, in the DevTools, can we
Uh-huh.
see the difference? Or
I don't think so.
So I guess the question is, when you're developing Chrome extensions, you have a little bit more capabilities as compared to web applications. In other words, you have less restrictions, right? And so what you're asking is, can developer tools tell you about those restrictions?
that's right.
I think
And
no.
I think the answer is no, but I'm just having a hard time figuring out how we would do that. So perhaps, during office hours, come down, we can talk about that, and I can submit a bug on your behalf, or we can do it together. Thanks. Okay, if there are no more questions, thank you very much for coming. We've enjoyed presenting this to you. Hope you've learned something interesting.